Hi everyone. Today I want to show you and demonstrate how to create a machine learning model for loan defaults. So for any financial institutions that borrowing money, it's possible to create a machine learning statistical model that will estimate the probability that a borrower will fail to repay a loan using features like credit history, income, number of dependents, and so on. So lenders can use this predicted probability to price their risk, set credit limits, or comply with capital regulations. So I'm going to show you the data set you need. I'm going to build machine learning model in no-code environment in Graphite Note. I'm going to show you the key drivers to loan defaults, all the insights, and then I'm going to show you prescriptive analytics piece, meaning strategies with a goal to decrease occurrence of loan default in my business based on my dataset. I'll do that all in 5 minutes, so let's begin. Okay, so let's start with the dataset. I have 3,000 rows with different customers. I'm a financial institutions borrowing money, and my customers are described with their age, income, credit score, loan amount, number of dependents, their employment status, marital status, and if they previously defaulted. So if they previously had a trouble to repay the loan. The most important column will be loan default, yes or no. This is my way to train machine, to show machine that this is how the default no looks like, and this is how the default yes look like. So every single row is a training machine. How does a loan default yes or how does a default loan default no looks like? And this is what we call a target feature or target column in machine learning. So this is the process of data labeling. If you label your data set like this, it's very simple in Graphite Note to create a classification model on this target column, loan default, and I'm going to demonstrate that in a second. So let's create a model that will be able to predict loan default based on this 3,000 historical data. So I'm going to create a new model in Graphite Note. It will be a classification and binary classification problem because my target column is yes, no, so binary, two values. I'm going to select my dataset, name it, and create a model. So the model is created, but I need to define the scenario in Graphite Note. So it's very simple. Just first step is to select my target. So what it is that I want to predict? I want to predict loan default column. It can have a yes or no values. This is from historical dataset distribution. Next step, do I want to include or exclude any columns? I can go with the defaults. It's worth mentioning that Graphite Note is going to automatically discard some columns like customer ID because they cannot bring any value to target column. It's just customer ID. Then we have advanced parameters, which algorithms to run, what will be the training and test dataset size split, what will be our metric of success, and so on. This is more advanced for data analysts and data scientists. If you're not one, you can just go with the defaults here and click here if you want us to create automatically strategy and actionable insights for you with goal to increase the frequency of loan default no, which is a good thing because a loan default yes means something bad. It means that someone couldn't repay their loan. So with all these steps, we just go to the last step, run model. We're explaining what we are going to do, and you just click run scenario, and I'm going to pause video now and run scenario. Okay, and the model is run after 2.5 minutes, and now we can access performance tab on our model. Here you can see all the explanation about model health check, accuracy, if the model is strong or not. We can definitely see that the model is very strong, which means it can generate new data and new loan applicants very well. And let me just jump to the one of the most important things here. It's a key driver. So I, as a business, I really want to know what's driving loan default to be yes or no. And I can see that the most important columns in my dataset are employment status, marital status, number of dependents, and so on. So employment status has almost more than 30% importance. And when I add together all the feature importances here, I got 100%. So like loan amount is not as important as I thought. Actually, employment status or even number of dependents and customer age are more important for my model to drive loan default being yes or no. Within every column, I can see the distribution. So for employment status, I can see that if someone is self-employed, there's a 30% more chance that they're going to default than the other, like unemployed, employed, or retired statuses. I can see the same for marital status, like widowed or married are in danger, number of dependents. Higher number of dependents is increasing the loan default chance, and so on and so on. So we can build the whole strategies, and you can see all the sweet spots and ideal persona for loan default yes or loan default no here on this screen. I don't want to bother you with all the details you can see here. It's about model fit and accuracy and confusion matrices and all the algorithms we trained here, and we picked the most accurate one based on your data. Let me just jump to the predict part. And this is when I have a new loan applicant and I have a model, which I have right now, I can actually predict this what if scenario. If someone is employed, divorced, one dependent, and so on, they're 18, they're asking for this for this loan amount. I want to predict the outcome. So they won't default, and I'm 95% sure they won't. But what if they are single and they are retired and they have 5 dependents and they are 55? Now the probability is different. Now there's a 20% chance that they will indeed default based on historical value. So this is the most important thing. This model is trained on particular data. If you ask ChatGPT or similar language models, hey, how can I decrease my loan default in the company? You're going to get something very general answer. Here, you will be able to create with predictive analytics, to create predictions for every new loan applicant based on historical values from your data, and you will be able to create a full strategy based on your data. This is specific strategy with the goal to decrease loan defaults in your company. This is the whole overview of all the columns that we have and their importances, strategic directions based on your data with the questions why. So we are explaining the narrative, why this is a good strategy because of what we find in your data. And then we have proposed objectives and KPIs to track these objectives, how to decrease loan defaults in your financial institution. And finally, we have actionable insights, deep dive reasoning between among all the most important feature importances that we found out. For example, number of dependents. Why do more dependents increase default risk? Why can't borrowers compensate for this? And then we have actionable insight. What maybe you can do? Maybe offer family-centric financial planning services, and so on and so on. I won't read through all of this. It's very comprehensive, very detailed strategy document with even strange statistics or outliers that we are trying to explain that we find out in your data. The frameworks chosen and justification of them for this strategy document, and step-by-step implementation guidance for this strategy for your company. This is the ultimate goal of any data analytics. This is prescription. It's not just telling you what happened and what will happen with predictions. It is telling you exactly what you should do to achieve a goal. And in this case, our goal is to decrease the loan defaults in my financial institution. Hope you like it. If you have any questions, just shoot me an email, find me on LinkedIn. Cheers, bye.